Hello, I made this VTOL tailsitter kind of thing out of foam board last year. The flight controller that I was using on this was basically just an Arduino program of my own design with gyro-only stabilization, so it didn't have any auto level or anything like that. And it was a bit tricky to fly, but it did fly kind of okay, although the vertical descent was very difficult, so it was almost impossible to bring it down and land it on the ground again, because I think when you're descending vertically, the airspeed going over the elevons is slower than it is when you're ascending or just hovering normally. And it got me wondering, what if you could confine the airflow completely so that all of the air coming from the prop was going over the control surfaces? So that sort of got me wondering about making a ducted fan sort of a thing with vanes almost inside the duct itself, so that all of the air had to go over the control surfaces. But I sort of put it aside for a while, thinking that I might try it later on. And in the meantime, I came across Ardupilot, and I noticed that last year the tailsitter frame type support had been added to Arduplane. So I thought I might give it a try. This is a video here by Dennis Baldwin, who probably a lot of people who subscribe to my channel already know of. And he said he got it up and running pretty easily. This is just with a regular flying wing. So this got me very interested, and I also happened to watch a presentation by Andrew Tridgell, who is one of the main maintainers of the Ardupilot project, and he said that with just a few minor changes to the plane code, he was able to get tailsitters working fairly well. And there's also a pretty good thread dedicated to this on Ardupilot forums, which explains a lot of how to set it up and everything. So I decided I would actually go ahead with making one myself. But instead of using the more typical flying wing layout, what I wanted to try was this slightly crazy idea with two ducted fan sort of things with directionable fins at the bottom like this. So in effect it's the same, from the flight controller's point of view, it's the same as a flying wing, but it's nice that the props are fully enclosed like this. And one of the reasons I wanted to try this was I thought it might be cool to have this as a detachable pod to stick on the bottom of a glider to function as a kind of a high start mechanism, where you get the glider up high, then this thing would be able to drop off and come back and land, and then you can fly the glider. Very impractical, I think, and now that I've given it a little bit of a try, I can tell you for sure that it will be quite impractical. Sucks a lot of power, this thing. So I'm thinking that to actually do this in the future, I might just go back to a more normal quadcopter sort of arrangement, maybe a quadcopter that sits in a frame that's around the plane like this and just sort of holds the plane there, maybe like that, is a bit more practical. Because another problem that I'm having with it is that because I'm using 4-inch blades, they're very inefficient, and it's just not very good at lifting weight. So ideally you want props that are a lot larger for this kind of thing. Anyway, so that's the background behind how this thing came to be and why it has no wings, at least not yet. So it's probably not going to need wings of its own, that's what I'm thinking. Anyway, so I got to looking for something that I could put my propeller blades in that would fit nicely, and as it turns out, these drink bottles were just the right size to put a 4-inch prop in. So I bought a couple of those and promptly threw away the sugar water inside them. And unfortunately there's only a part of it that's straight along the sides, so I managed to get about 17 centimeters from here to there roughly. Just before I glue this all together, I thought I might show you what it looks like in pieces first, so you can get an idea of what I was thinking when I designed it and how it all fits together. So these tubes or pieces of the bottle are quite soft and they don't hold the shape very well on their own, so it wouldn't have been enough to just stick something on the side of them in the middle between them, just in here. So that's why I've gone with this design which envelops them all the way around with 3 ribs or whatever, I don't know what you would call these exactly, but these pieces here are all the same, and the interior of this is a circle which just fits onto the outside of the tube. So that's what they all 3 of them look like that. And they are held in place along the side with some of these 2 that are like that go on the outside corners, and 2 in the middle that are like that, a little bit different. And then on top of that we have this piece, which is obviously for the motor to go, and this also has some little tabs in the corner just for positioning, and you can see that that piece there, oops, there's a little bit here that sticks out a little bit, just enough to sort of get it in the right place. So at each end there's actually going to be two thicknesses of plywood, so we're looking at about 6mm of plywood on the top and the bottom, so it should be fairly strong, I think. And on the bottom, this is the piece that I have not really figured out exactly what I'm going to do for how the vanes are going to be mounted. Well, I have a rough idea, but you can see I've put some little marks here with pen. These are where the hinges for the three vanes, or whatever what would you call these? Vanes? Directional flaps or whatever. These are where they're going to mount for the hinge point, but haven't really thought too much about how they're going to be mounted exactly. Probably a little bit of FR4 or something sticking up that way, so I might have to actually add a little bit more plywood around these parts before I complete everything. But the thing about this piece and the top piece is that the tube cannot go through this. So unlike this piece, which is a full circle which allows the tube to slide through, the top and the bottom don't let it slide through. So my thinking is that I might be able to get away without using any glue to hold the tube in place, because it can't slide out through this one and it can't slide out the other direction through that one. So possibly might not need to glue it. I tested some glues on this stuff. It is really hard to glue. Super glue didn't work. Epoxy, I didn't even bother trying it, because I've actually used this stuff to put epoxy on while I'm mixing it, because I know it's not going to stick to it. Hot glue did work, but the problem with hot glue is that it deformed the plastic quite easily. It didn't take much heat at all for it to sort of shrink into itself and go hard. So I really don't want to do that if I can avoid it, but maybe a good idea eventually to have some hot glue, just a little bit of hot glue, like in these corners there where my thumb is, just, I don't know, maybe stop vibrations or something like that. Anyway, so once we have those two outside tubes constructed like that, they're just going to sit together on this central frame section. So I wanted this piece to be nice and flat along the bottom, so it'll be easy to work on. So if I turn this over here, this top edge is perfectly flat. So as well as being easy to work on, what I'm thinking is that the final piece of structural strengthening will be just a slab of foam board across here like that. Otherwise it's going to be weak in this in that movement. It's a bit hard to do with one hand, but obviously you're going to need something across here. So yeah, I think just a piece of foam board will go on there. These tubes are a fair bit heavier than I expected. It's 22 grams, and the total weight of all of this stuff so far before gluing is 157 grams, and about 53 grams for the motors. This is actually holding together quite nicely with no glue. So yeah, I'm pleased that all my CNC designing and parts were accurate. So after just telling you about how those two end pieces would stop the pipe from sliding in and out, I have now completely forgotten about that and glued the two ends on before I put the pipe in. But fortunately though, this end, there's not much to it that stops the pipe. There's just these little tab bits here, like that, and the pipe is fairly flexible, so I think I should still be able to get it in there, let's hope. Okay, the glue is dried now, it's gone together fairly well. It turns out that the problem of getting the tube into the ribs is not actually a problem at all, because these bits here are just quite small, and the tubes being quite flexible and resilient, it doesn't matter, so you can just sort of push them in against these tabs, and it just makes it a little bit harder to push down, but it goes in there pretty easily still. So at the bottom there, of course, once the tube goes in underneath that little tab, then it's going to be quite difficult to get out. So that's why I haven't quite pushed it down all the way just yet. I might mount the motor in there, because obviously changing the prop and everything's going to be a pain in the ass once these tubes go in, or not so much the tube, but when the control vanes go across the top here, then it's going to be a pain in the ass to get at the motor. But anyway, as far as the alignment and the positioning of everything, it turned out very nicely. This bit here is perfectly flat. There's actually not much, now that this glue is dried and all of these joints are solid, there's actually almost no flex in this direction on these pieces here. So I might just hold off on putting that piece of foam board on here that I was talking about, because when I do that it's going to be a lot harder to look inside here and get access to this area. Before the glue dried, these little thin sections here felt very thin and flimsy, and I was actually thinking about maybe having to put another piece of something across the top to reinforce them. They just felt so weak, but now that the glue is dry and the outside of this frame cannot move, plus it's 6mm thick now, effectively, you see the thickness there, now they feel really good. So I'm glad I didn't bother to do any premature reinforcement of this, because I think it'll be fine just like that. Alright, I've put the motors in there now. They are fortunately sitting into place exactly where they're supposed to be, and nothing is going wrong. There's about 5mm of clearance there, which is pretty lucky really, considering these were the first of the large bottles that I really looked at, and they were just the right size. So yeah, I think maybe a little bit less clearance would have been nice, but I didn't want to take too many risks with not getting things aligned properly and having the props hitting the inside of the tube. That would have been kind of annoying. But anyway, that's looking good, and I'm turning my attention now to the other end, which is rather more complex, and I still haven't completely figured out what I'm going to do, although I have a pretty good idea. You can see I've printed the templates for these out here. I'm just going to make them out of 1/8 inch balsa, or roughly 3mm balsa, so I'm just going to cut them by hand with a craft knife out of that. And originally I was thinking of a fairly simplistic hinging system, and I was going to use some of this stiff piano wire, or whatever you call it, that we use for our push rods as the hinge, and just cover the balsa with some packing tape or something to reinforce it. But it occurred to me that this motor, or these motors here, at full throttle they could be putting out about 500 grams of thrust or so, and almost all of that thrust, all of that air is going to be coming into this area and hitting these vanes, which are 4 centimeters wide, and they're going to be at maximum deflection 45 degrees each way. So they're going to be catching quite a lot of that 500 grams or so of thrust, and I just became a little bit concerned that a hinge like this, although they are fairly stiff, I think if they caught all of that energy coming at them on those vanes like that, they might be inclined to bend a little bit and sort of bind up and not really move the way they should freely. Plus they might even break or come out of their mountings or something like that. So on my trip to the hardware store today, I came across these, which are from, I think, K&S Precision Metals in the United States. They make these. Well, they make all kinds of things, but these are aluminium tubes, 2mm and 3mm sizes, and the way they've made them is such that the 2mm can go inside the 3mm, and it's fairly easy to turn, but there's no play. It's almost like they intended this to be done so that you could use them as a hinge or something. So that, I think, is what I'm going to go with, and of course that is very strong. And it also means that the torsion, if you wanted to connect your servo to one of these and twist it, you'd get a lot better twisting force going all the way through to the other end than you would with one of these, I think, because these tend to, if you twist one end, the other end doesn't always follow along quite as well as it would with something like that. So this is what I was meaning. Cut the vane in half, cut out a 3mm section, and then put one of these little aluminium tubes in there so that when it goes back together again, it'll be the original size, but it'll have a hinge in the middle without having any drag on the side of the vanes, like nothing sticking out there, it's just flat. It's just held into place with a little bit of CA at the moment, but I'm going to put some epoxy along this join here now. Okay, the epoxy's dried on these pieces, they're looking pretty good, feeling quite strong. That's not the only reinforcement I'm going to put on them. I don't quite trust that on its own, so I will put a little strip of something going across like that, probably, I don't know, wood or maybe a carbon strip, I don't know. Anyway, I'm starting to think now about servos. My first choice was to use these ones here because they're quite cheap and fairly strong, metal gear, and I have a big box full of them. Geez, what happened? I used to be a multi-rotor guy, now I've got boxes full of servos. But the problem with these is that they are 180-degree rotation ones. So if I go like this, it goes all the way back there, but I didn't really want that because if something goes wrong, it opens up the possibility of snapping the vanes as they go too far across. So I think what I'll do is go with these other ones that I have, which I bought for something, and then when they arrived in the mail I completely couldn't remember what I bought them for. May have been this project actually, I don't know. But they are slightly better quality, I think. They're Emax 9051 servos, about half the weight, which is good. Probably not quite as strong though, so I'm a little bit concerned about that, but they are at least 90-degree rotation, and they're probably a little bit more precise, and precision is going to be fairly important for this job, I'd imagine. Speed is probably about the same. Speed is probably quite important, but I imagine the speed between that one and these ones is quite similar, so yeah, strength is probably the main thing that these are lacking, but given the fact that the air is going to be hitting approximately equal areas on both sides of the pivot point, they're not actually going to be fighting the wind to turn, so hopefully they shouldn't need to be super strong to carry out this job. Well, after a very long session using the CAD program to design dozens of intricate little parts, and then another very long session cutting them out on the CNC machine, you can see that's about half of them there. Oh, and these as well. I have decided to make another plate or another ring to go on the outside of that there, mainly because the one that I had on there just didn't really have enough of the details that I'm going to need when I started to think about it a little bit more carefully. And the other thing that's nice about this is that I don't need to have it up on here to work on it, so I don't need to have this carrying it around with me all the time, and I can put it on a flat surface while I'm working, which is a lot easier. So I'll just give you a quick look at this before I've glued most of the pieces up. The central pieces of these ones, which is just two pieces of FR4, just sort of stuck together, and they will slot into that little cutout there like that. So there'll be 6 of those, and they'll be supporting the 2mm aluminium tube like this. And to stop it sliding off, you can see there's a sort of an empty, they don't slide actually already, so it might not have needed this, but in theory they can slide. So this little hole here will be plugged by another piece of FR4 and a piece of plywood there, just to stop the tube from sliding out that end. And at this end I'm going to put a piece of this, or one of these contraptions, and I'm going to obviously cut that tube there, and I'm going to attach this here just as stoppers to stop the tube sliding out that end. And I'm going to do that with small self-tapping screws excuse me, because I want to make it so that I can take this off again, so I don't want to use glue, and then I'll be able to take these rods out and take the vanes off if I want to change them or replace them or something like that. And I'd also like to be able to stick this on here without gluing it. I'm not really sure how I'm going to do that. Maybe some more self-tapping screws or something. But since there's so much work gone into this piece, I'd like to just make them a little bit more modular, so I can maybe take this off and change it, or change something in there without having to lose all the work that I've put into here by committing to wood gluing them together or something too permanent. This little mounting piece here on the inboard side in the middle is a slightly different one. You can see it has a bit of stuff overhanging to the side with another hole in it. That's going to be where the servo goes on this plate here, this area. So these wooden bits are going to be building up a little wall around the servo so that it can't slip out sideways. And the hole on the end of the servo there, right about the middle of the screen, is going to go there. And then there's going to be an actuator from here to that vane. And then finally these pieces are going to go between the three vanes, so this little hole in the middle will be in the middle of the middle vane, and the hole at the end there will be in the middle of this one there, just to transfer the rotation between them. Anyway, let me again put it all together so that you'll see what it all looks like when it's done. So that's how it's going to look. I'm just putting these in there to hold it in place while the glue's dried to make sure they're all going to be straight. So here's how the three vanes will all be connected to each other. Along the top of each one of them I've put a little straightened out paper clip, and I've embedded it in the top of the vane so that when you look at it from the side you can't see it, and it's holding the cross piece in. And on top of that, because I don't quite trust that, I'm just going to put a little bit of this carbon strip like that on each side to make sure it stays put. And the connection to the servo here is just sort of loose there at the moment, but you can see a little piece of wire sticking in there, and what that is one of these things that I had from another plain kit that I didn't use. And if you look at that end there, it's got a little screw thread on it, and I used that to drill in from this side, so it goes into almost halfway along, and that's going to be where the servo pushes and pulls on this middle vane. Not too happy about this because it's pushing and pulling on the soft balsa, so I might put a little bit of reinforcing something around there, but probably not. I'll just see how it goes to start with. So that's how the servo connection goes in, and I'm quite pleased with the amount of play that I get. It's probably slightly less than a millimetre. You can move fully to each end with no binding or resistance. When they get to the end, there's no, like, you can't hear the servo trying to push further or anything. So I think it'll be pretty good. I think it might have been slightly better to have this cross member on the inside, because that would have meant that I could feather these trailing edges here down to a narrower point than just a flat edge like that. I have sanded the front of these vanes a little bit there, but ideally it would have been the other way around, but I think it'll be fine anyway. I've just been doing some checking of the weight, and almost everything's on here. I think it's just the flight controller and the receiver that's not on here at the moment, and it's at 289 grams, and the batteries I'm thinking of flying it with are a 3S 1000 milliamp hour, which will bring it to 382ish, say 400, and a 4S 1300 milliamp hour. This one might give me problems with getting the CG right, so I'm probably not going to be using it, but I might give it a try, and that will be, say, 450 grams. And as it would turn out, I did some testing with my good old thrust test stand, and the hover throttle for both of these is going to be, in this case it's going to be a little bit above half throttle, and in this one it's going to be a little bit below half throttle. So either battery power wise should be perfectly fine. It's just the CG, like I say, is going to be an issue with this one, I think. A big blast of full throttle, it just tips over. but it does lift off, okay. Well, that's 3S, and it feels like it's taking just under 3/4 throttle to lift off my hand. Can't believe how noisy this thing is. I'm a little disappointed. I thought it would be a bit quieter than that.